We use numbers every single day, but have you ever stopped to think about what they really are? It turns out the number 2 you use to count a couple of books is a totally different beast from the number pi that helps you measure a circle. So today, we're going to take a quick tour through the entire universe of numbers. Let's dive in.
So let's start with the big question. Are all numbers the same? You might think, well, a number's a number. But the answer, and this might surprise you, is a big no. They actually belong to different families, each with its own rules and its own job to do.
And to get a handle on these families, we've got to go way back. Let's rewind to the very first numbers any of us ever learned. The ones you use to count your toys or your fingers. Right. We're kicking things off with the absolute foundation of all mathematics. The simple, basic act of counting stuff. And here they are, the very first family, the natural numbers. These are your bread and butter, your ABCs of math. If you can use it to count physical objects in a room, it's a natural number. You know these guys, right? 1, 2, 3, 25, 100, and on they go. The main thing to remember here is that they're all positive whole numbers. No fractions, no decimals, just pure counting. Here's a perfect real-world example. There are 25 students in the class. You're using a natural number, 25, to describe a real, countable group of people. See? Easy enough.
But wait a minute, what happens when you have nothing to count? Or what if you need a number to show that you owe someone money? For that, our basic number toolkit is going to need a bit of an upgrade.
So our first upgrade is super simple, but it is an absolute game changer. We take all those natural numbers we just talked about, and we add just one new character to the team, the number 0. And just like that, we've created a whole new set called the whole numbers.
So yeah, the only difference is adding 0. It might seem totally obvious to us now, but wow, the idea of having a symbol for nothing was revolutionary. It took humanity ages to figure out, and it unlocked everything from advanced algebra to the computer code running on your device right now.
Okay, now let's get a little negative. We're expanding our toolkit again. This time we take all the whole numbers, that's 0 and all the positive counters, and we add their negative opposites. When you do that, you get the integers.
And you see integers all the time, probably without even thinking about it. Just look at the weather. If it's 5 degrees below 0, you're using an integer, -5, to describe something real. Our old natural numbers just couldn't do that. All right, so we've got our positive whole numbers and our negative whole numbers. But what about all that empty space between them on the number line? Well, it's time to zoom in. Welcome to the world of rational numbers. And the key to understanding them is right there in the name, ratio. A rational number is just any number that you can possibly write as a ratio, or a fraction of 2 integers. Simple as that.
And this family is huge. It includes the obvious fractions, like 1/2. It also includes decimals that stop, like 0.75, because that's just 3/4, right? Even decimals that repeat forever, like 0.333 and so on, that's just 1/3. And get this. All the integers are also rational because you can write any of them as a fraction just by putting it over 1.
We use these constantly. Anytime you're in the kitchen following a recipe, that 3/4 of a cup of flour, yep, that's a perfect everyday example of a rational number doing its job. So we have integers and we have all the fractions filling the gaps in between. You'd think that's got to be every possible number, right? Well, things are about to get a little weird.
Okay, say hello to the rebels of the number world, the irrational numbers. These are the mysterious ones, the numbers that refuse to be pinned down as a nice, neat fraction. Their decimal form just goes on and on and on forever without ever repeating a pattern. And you've definitely met some of these guys before. The most famous one, of course, is pi, essential for anything to do with circles. Then you have the square root of 2, a number that supposedly terrified the ancient Greeks. And then there's the mathematical constant, e, which is kind of the bedrock of calculus and finance. These numbers are a completely different kind of beast.
So here's the bottom line. It all comes down to this one simple difference. Rational numbers can be written as a clean fraction, which means their decimals either stop or they fall into a nice repeating pattern. Irrationals? Nope. You can't tame them with a fraction, so their decimals are just an endless, non-repeating stream of digits.
Okay, deep breath. We've explored the counters, the integers, the fractions, and those wild, endless decimals. Now it's time to put all the pieces together and look at the big picture.
This is it, the grand finale, the whole shebang. The set of real numbers is what you get when you combine everything we've talked about. You take all the rational numbers, all the irrational numbers, and you put them together. They fill every single conceivable point on the number line with absolutely no gaps.
All right, let's do a quick pop quiz and see if you're with me. We saw that the square root of 2 was irrational. So what about the square root of 9? Is it rational or irrational? What do you think?
It's rational. Did you get it? Why? Because the square root of 9 isn't some messy, endless decimal. It's exactly 3. And since we know that 3 is an integer, we can write it as 3 over 1, which makes it a proud member of the Rational Numbers Club.
And that just about wraps up our tour. But here's the key takeaway. These aren't just abstract ideas for a math class. They are literally everywhere. So I'll leave you with this challenge. Just look around you right now. Can you spot a rational number on a receipt? An integer on a thermostat? A natural number counting the items on your desk? The numbers universe isn't some far-off place. It's all around you.